നിശബ്ദേ. ഹലോ ഹലോ
ഹലോ.
ആ
ഇന്ന് എന്താ ബാക്കി യൂട്യൂബിൽ കയറിയിട്ടുണ്ടാവും അല്ലേ ബാക്കിയുള്ളവരെ? ഞാൻ കണ്ടു സാറിനെ കണ്ടേ. ജലീൽ സാറൊക്കെ കയറിയിട്ടുണ്ടല്ലോ അല്ലേ? കണ്ടായിരുന്നു. എന്റെ സാറ് കയറിയിട്ടുണ്ട്, ഞാൻ കണ്ടിട്ടുണ്ട്. ഹഫ്സിത ഉണ്ട്, ഉണ്ട്, എല്ലാവരും ഉണ്ട്. സ്റ്റാർട്ട് ചെയ്യാം അല്ലേ? ഹലോ.
ഗുഡ് മോർണിംഗ് ടീച്ചറെ.
ഗുഡ് മോർണിംഗ് സർ. ഗുഡ് മോർണിംഗ് രമേശൻ സർ. നമ്മള് സ്റ്റാർട്ട് ചെയ്യാം.
ഓക്കെ.
ഹരി, മറ്റേ ലിങ്ക് പ്രൊവൈഡ് ചെയ്തന്നില്ലേ? അത് ആക്റ്റീവ് ആയില്ലേ? സ്റ്റാർട്ട് ചെയ്യാം അല്ലേ? Respected Chief Guest and Resource Person of the Day, Dr. Ramesan, Associate Professor, Department of Chemistry, University of Calicut, faculty members, research scholars, and PG students from various colleges and from my own college, my colleagues, a very good morning to you all. Today, we have the third day of the 5-day faculty enrichment program on polymers for environment. This is as a part of observing the century of the first publication by Hermann Schrödinger in 1920. As a part of observing that special year, 2020, we are conducting this 5-day faculty enrichment program on polymers. And today we have Dr. Ramesan, Associate Professor, University of Calicut, as the chief guest and the resource person. Dr. Ramesan has great experience in teaching, research, and learning in university itself from 2005 onwards, and we are lucky to have such an eminent resource person. And I request Hafsida, MSc student, for the welcome address. Hafsida.
Okay. Miss, may I audible?
Yes.
Okay.
പറഞ്ഞോളൂ, കേൾക്കാനുണ്ട്.
Okay. Respected Chief Guest of the Day, Dr. M.T. Ramesan Sir, Shantakumari Ma'am, faculty members, research scholars, postgraduate students from various colleges and my own colleges, a very good morning to all with a warm greeting. It is my pleasure to extend a warm welcome on behalf of Department of Chemistry, Majlis Arts and Science College. Today is the third day of 5-day faculty enrichment program on polymers for environment. Today we have M.T. Ramesan Sir, Department of Associate Professor, Department of Chemistry, University of Calicut as chief guest and a resource person. Sir have a great experience on academic research and administration. He had completed his PhD on RRI, River Research Institute, India, MG University, and postdoctoral fellowship on South Korea. And today his topic is preparation, structural characterization and properties of nanocomposites based on different polymer blends. On behalf of Department of Chemistry, I extend a warm welcome you, sir, today's program, and also welcome Shantakumari ma'am for chairing today's section, and Ms. Suganya KP, who are expressing vote of thanks for today's program. And also, once again, I extend a warm, heartily welcome all academic communities who are assembled here. Thank you.
Thank you, Hafsida.
Thank you.
And today we are having the third day of the 5-day program. And Dr. Ramesan is talking on structural characterization and properties of nanocomposites based on different polymer blends. And we are very happy and proud that Dr. Ramesan has been awarded world's top 2% scientist in 2020 in the polymer category. And this is published by Stanford University, USA. Sir, we are all proud of you, sir. We are happy.
Thank you. Thank you.
And Dr. Ramesan has 117 publications in international journals, and he has published 8 books, attended 15 international conferences, and he is a life member in Asian Polymer Association and also a life member in Association of Chemistry Teachers, Mumbai. And the topic is structural characterization and properties of nanocomposites based on different polymer blends. And we know that nanocomposites are when nanoparticles are incorporated into polymer matrix, it was found that there is tremendous improvement in properties like the mechanical properties, tensile strength, thermal conductivity, electrical conductivity, optical clarity, flame retardance. Such properties are greatly improved when nanoparticles are incorporated into polymer blends. So the materials will have better properties when nanocomposites are prepared based on polymer blends. So this is his research area and today's topic. Now the advantage of this nanocomposite is that the amount of nanoparticle required is very small, 0.5 to 5% only. And the property improvement is very high. And these composites have applications in various fields, like in automobile engineering engine parts, then in computer chips, food packaging, and these have great resistance to permeation of gases. So they are used in food packaging, gas barriers, and wide applications are there. So Ramesan sir will be telling us about these nanocomposites, their applications. And today we are starting the third day technical session in the 5-day program. I express a hearty welcome to Dr. Ramesan sir to this program. Ramesan.
Thank you for your nice presentation regarding me. And also I express my sincere thanks to Professor Shantomari for inviting me as a resource person for this. I directly go to the presentation, okay?
Okay, sir.
Some problem. Wait a moment. Slide presentation എവിടെയാണ്? Present now. ഒരു ചെറിയ പ്രോബ്ലം കാണുന്നുണ്ടല്ലോ. പ്രസന്റ് നൗ സ്ലൈഡ് വരുന്നില്ലല്ലോ. ഓപ്പൺ ചെയ്യാൻ പറ്റുന്നില്ല. ടീച്ചർ പ്രസന്റ് നൗ കൊടുത്തിട്ടേ അത് ഇതൊരു പുതിയ കമ്പ്യൂട്ടറാണ്. ഞാൻ എന്റെ കമ്പ്യൂട്ടർ കംപ്ലൈന്റ് ആയിട്ടാണ് ഞാൻ. അപ്പോ അതെങ്ങനെ എൻ്റയർ സ്ക്രീൻ യുവർ എൻ്റയർ സ്ക്രീൻ വിൻഡോ ടാബ് അങ്ങനെയാണല്ലോ കാണിക്കണേ. എൻ്റയർ സ്ക്രീൻ ആണോ? ഇതൊരു പുതിയ കമ്പ്യൂട്ടർ ആയതുകൊണ്ടേ ഇത് ഓൺ ആക്കിയിട്ടുണ്ട്.
നേരത്തെ സ്ലൈഡ് ഓപ്പൺ ആയിട്ട് കിടക്കല്ലേ?
അത് ഓപ്പൺ ആയിട്ട് കിടക്കുവാണ്.
അപ്പൊ പിന്നെ വിൻഡോയില് കൊടുത്താലേ അത് കാണാറുണ്ട്.
ഷെയറിംഗ് വരുന്നുണ്ടോ?
വരുന്നുണ്ട് സർ.
ഓക്കെ ഓക്കെ. ഇതൊരു പുതിയ ലാപ്ടോപ്പ്. അപ്പൊ എന്റെ ലാപ്ടോപ്പിന് അതിന്റെ ഇത് കംപ്ലൈന്റ് ആയിട്ടിരിക്കുക. അപ്പൊ ഞാൻ ഇന്നത് വേറെ ലാപ്ടോപ്പിൽ
പ്രസന്റ് ചെയ്യേണ്ടി വരും. പ്രസന്റ് വന്നിട്ടില്ല, സ്ലൈഡ് വന്നില്ല.
സ്ലൈഡ് വന്നിട്ടില്ല അല്ലേ?
സ്ലൈഡ് സെലക്ട് ചെയ്താല് വരും.
ഇവിടെ പ്രസന്റിംഗ് ആണല്ലോ കാണിക്കുന്നത്. ഷെയറിംഗ്
യു ആർ പ്രസന്റിംഗ്. സ്ലൈഡ് വന്നില്ല, പ്രസന്റിംഗ് കാണിക്കുന്നില്ല. സ്ലൈഡ് ക്ലിക്ക് ചെയ്താല് സ്ലൈഡ് ഓപ്പൺ ആവുമായിരിക്കും. നേരത്തെ ഓപ്പൺ ആക്കി ഇട്ടിട്ടുണ്ടെങ്കിൽ ഓപ്പൺ ആണല്ലോ അല്ലെ?
സ്ലൈഡ് ഓപ്പൺ ആക്കിയിട്ടുണ്ട്. ഞാൻ മറ്റ് വിൻഡോസ് ഒന്ന് കളഞ്ഞു നോക്കാം.
വരാൻ തുടങ്ങുന്നുണ്ട് സർ, വരാൻ തുടങ്ങുന്നു. വരാൻ തുടങ്ങുന്നു.
നോക്കട്ടെ. ബ്ലാങ്ക് സൈഡ് ആണ് കാണിക്കുന്നത് അല്ലേ?
ഇപ്പൊ കണ്ടത് ബ്ലാങ്ക് സ്ലൈഡ് ആയിരുന്നു. ഞാൻ ഒന്നുകൂടെ സ്റ്റോപ്പ് പ്രസന്റിംഗ് കൊടുത്തിട്ട് ഒന്നുകൂടെ കേട്ട് നോക്കട്ടെ. ഓക്കെ സർ. സ്ലൈഡ് ഓപ്പൺ അല്ലേ ആവും ആദ്യം.
ഇങ്ങനെ സ്ലൈഡ് ഇനി ഒന്നുകൂടെ ക്ലോസ് ചെയ്ത് ഓപ്പൺ ആക്കി നോക്കണോ?
ആയിക്കോട്ടെ സർ, ഒന്നും കൂടെ ആദ്യം നമുക്ക് സ്റ്റാർട്ട് ചെയ്ത് നോക്കിയല്ലേ സർ.
Present, you are present. കാണുന്നുണ്ടോ സ്ലൈഡിലല്ലോ?
സ്ലൈഡ് വരുന്നില്ല. യു ആർ പ്രസന്റിംഗ് വന്നായിരുന്നു. സ്ലൈഡ് സെലക്ട്, സ്ലൈഡ് ആദ്യം ഓപ്പൺ അല്ലേ?
ഓപ്പൺ ആക്കിയിട്ടുണ്ട്. ഈ സ്ലൈഡ് ഓപ്പൺ ആവുന്നില്ല. ഒന്ന് നോക്കിയേ, ക്യാമറ ഓണാണ്. നോക്കിയേ, ഞാൻ ഇത് കൊടുത്തു. അങ്ങനെ ഷെയർ ചെയ്യാം. അതാ സ്ലൈഡേ. ഇത് സ്ലൈഡ് ചെയ്യാം, പക്ഷെ സ്ലൈഡ് വരുന്നില്ല. ഞാൻ ഒന്നോടെ ഓണാക്കി നോക്കട്ടെ.
ഇപ്പൊ വരുന്നുണ്ട്. ഓക്കെയാണ് സർ, വന്നിട്ടുണ്ട്. ശരിയുണ്ട് സർ.
ശബ്ദം ഓക്കെ കേൾക്കാലോ അല്ലേ?
ഇപ്പൊ സ്ലൈഡ് കാണുന്നില്ല.
ഇപ്പൊ
സ്ലൈഡ് ജസ്റ്റ് വന്നിട്ടുണ്ടായിരുന്നു.
ശബ്ദം കിട്ടിയ ശബ്ദം കിട്ടും ആദ്യം. ക്യാപ്ഷൻ വന്നിട്ടേ വന്നു. ഇനി ഇത് ഒന്നോടെ നോക്കി. അത് വരുന്നില്ല. മൂവിന്റെ മറ്റേ അത് വന്നിട്ടില്ല. അപ്പൊ വന്നില്ലേ? കമ്പ്യൂട്ടറിന്റെ പ്രശ്നമാണല്ലോ.
ഇപ്പൊ വന്നായിരുന്നു സാറിന്റെ
സ്ലൈഡ് അങ്ങ് വരുന്നില്ല. വന്നു. ഇനി ഒന്നോടെടുത്ത് ഒന്നോട് ക്യാൻസൽ ചെയ്തിട്ട് കൊടുത്ത് അത് വരുന്നില്ല. സ്ലൈഡ് പ്രസന്റേഷൻ വരുന്നില്ലല്ലോ. ഇതാണ് സ്ലൈഡ്. അത് മാത്രം വരുന്നില്ല. നേരത്തെ വന്നിരുന്നു.
ഒരു പ്രാവശ്യം വന്നു സർ, സ്ലൈഡ് കണ്ടു ഞങ്ങള്.
സെലക്ട് ഡിപ്പാർട്ട്മെന്റ് പോണ്ടി വരുമോ? ഞാൻ ഒന്നോടൊന്ന് കയറി നോക്കിയാലോ? ടീച്ചറെ, ഞാൻ ഒന്നോടൊന്ന് ഇത് പുതുതായിട്ടൊന്ന് കയറി നോക്കട്ടെ.
അതെ അതെ സർ, അതെ. ഫയൽ ആദ്യം ഒന്ന് ഓപ്പൺ ചെയ്ത് ഒന്നും കൂടെ റെഡി ആക്കിയിട്ട് അത് വന്നു. എന്തായാലും ഒന്ന് വന്നിട്ടുണ്ടായിരുന്നു. ഒന്നും കൂടെ ക്ലോസ് ചെയ്തിരുന്നു. ഹലോ എവരിബഡി. ചെറിയ ടെക്നിക്കൽ പ്രയാസങ്ങൾ ഉണ്ടായിട്ടുണ്ട്. നമ്മളെ രമേശൻ സാറിന്. സാർ ഒന്നും കൂടെ ട്രൈ ചെയ്യുന്നുണ്ട്. അതുവരെ എല്ലാവരും വെയിറ്റ് ചെയ്യുക കേട്ടോ. നേരത്തെ തന്നെ ഉണ്ടായത്. ഇപ്പോഴും ഒന്ന് വന്നു. ജസ്റ്റ് കുറച്ച് നേരത്തേക്ക്, ഒരു സെക്കൻഡ് നേരത്തേക്ക് കണ്ടായിരുന്നു സ്ലൈഡ്.
അവിടെ വന്നോ ടീച്ചറെ?
വന്ന് ഒരു സെക്കൻഡ് കഴിയുമ്പോ പോവാണ് സാർ. വരുന്നുണ്ടായിരുന്നു. ഇപ്പോഴും ഒന്ന് വന്നു. പക്ഷെ അത് ഹലോ ദീപക് ഉണ്ടോ അവിടെ? ദീപക് എന്തായിരിക്കും അതിന്റെ കാരണം? ദീപക് എന്തെങ്കിലും സജസ്റ്റ് ചെയ്യാൻ പറ്റുമോ? എന്തായിരിക്കും കാരണം? അതെയോ? ശരി ശരി. ഡിപ്പാർട്ട്മെന്റിലല്ലേ ദീപക്? ഇതിങ്ങനെ പോകാൻ എന്തായിരിക്കും കാരണം? എപ്പോഴും വരുന്നുണ്ട്.
അപ്പൊ ഞാൻ പറയുന്നത് കേൾക്കാലോ അല്ലേ?
ശരി. ഇപ്പൊ സ്റ്റേബിൾ ആണ് തോന്നുന്നു. നിൽക്കുന്നുണ്ട്.
ഇപ്പൊ സ്റ്റേബിൾ ആണ്. അപ്പൊ ഞാൻ അവിടുന്ന് പ്രസന്റ് ചെയ്യാം. ഞാനിപ്പോ ഇനി കൂടെ എന്തെങ്കിലും.
ഇപ്പൊ ശരിയാണ് സാർ.
ശരിയാണല്ലോ. ടാബ് മിനിമൈസ് ചെയ്താൽ എന്തോ പ്രോബ്ലം ആണ് വരുന്നത്. ക്ലിയർ ആണല്ലോ സ്ലൈഡ് അല്ലേ?
ഇപ്പൊ ഫസ്റ്റ് സ്ലൈഡ് ആണ് കാണുന്നത്. അത് ക്ലിയർ ആണ്.
ഓക്കെ. ഞാൻ സെക്കൻഡ് സ്ലൈഡിലേക്ക് പോകുമ്പോ പോകുന്നില്ലല്ലോ മോനെ.
ടോപ്പിക് ആണ് കാണുന്നത്.
അടുത്ത സ്ലൈഡിൽ ഇപ്പൊ സെക്കൻഡ് സ്ലൈഡ് വരുന്നുണ്ടോ?
ഇല്ല, അതേ സ്ലൈഡ് തന്നെയാണ്. സെക്കൻഡ് സ്ലൈഡ് വന്നിട്ടുണ്ട്.
അപ്പൊ നമുക്ക് let us start our seminar. Sorry for the inconvenience.
അത് സംഭവിക്കാറുണ്ട്. ചിലപ്പോ നമ്മൾ ടെക്നിക്കൽ വെബിനാറിന് അതിൻ്റെതായ സൗകര്യങ്ങളും ഇതുപോലെയുള്ള പ്രശ്നങ്ങളും ഉണ്ടാകാറുണ്ട്. ഇപ്പൊ സ്ലൈഡ് കാണുന്നില്ല ഞങ്ങൾക്ക്.
ഇപ്പൊ കാണുന്നില്ല?
ഇപ്പൊ വന്നിട്ടുണ്ട്.
ഓക്കെ. അപ്പം
ഫസ്റ്റ് സ്ലൈഡാണ് ഇപ്പൊ കാണുന്നത്.
ഫസ്റ്റ് സ്ലൈഡാണ് കാണുന്നത്. ഞാന് സ്ലൈഡ് ഷോ വലുതായിട്ടല്ലേ സ്ലൈഡ് കാണുന്നത് അല്ലേ? ആണല്ലോ.
ഇപ്പൊ സ്ക്രീനില്ല.
കാണാവുന്നതാണോ? എനിക്ക് ഞാനിപ്പോ വലുതാക്കി.
സെക്കൻഡ് സ്ലൈഡിലേക്ക് ഒന്ന് പോയാൽ സ്റ്റേബിൾ ആണോ നോക്കാം.
ഇല്ല, ഇനി പ്രശ്നം വരില്ല.
ഇപ്പൊ കുഴപ്പമില്ല സാർ. കാണുന്നുണ്ട്. സ്ലൈഡും കാണുന്നുണ്ട്.
Sorry for the inconvenience. Let us start my presentation. My topic is preparation, structural characterization, and properties of nanocomposites based on different polymer blends. As you know that polymers are different types of polymers. For example, some reactive functional group containing polymers are there. Some polymers are not reactive. For example, reactive functional polymers, for example, polymethyl methacrylate or polyvinyl acetate or polyvinyl alcohol. These polymers containing reactive, for example, polyvinyl alcohol, it contains reactive OH group. Polyvinyl acetate containing ester group is there. PMMA, similar way. And for example, Teflon, if you take Teflon as a system, reactive fluorine or chlorine function, for another example, PVC, that contain chlorine group. These type of polymers are functional group containing polymers. And some other, they are simply, we can say that they are polar polymers. And some other polymers, for example, polypropylene, polyethylene, polystyrene, they don't have any functional group. So we can say that they are non-polar polymers. So if you want to prepare, or if you want to introduce a functional group into a non-polar group polymer, like for example, polypropylene, we want to combine a functional group. It is not so easy. It is a tedious process, and it is economically not viable. So polymer blends. The polymer blend, you are all well known about polymer blends. Polymer blends are the simple mixtures of two or more polymers that mix up together to create a new material. What is the aim of the polymer blend? Aim of the polymer blending is the modification of individual polymers, and by blending we can reduce the cost of that material, also improving the final properties and gaining high functional materials. In other words, polymer blending is one of the cost-effective methods for developing advanced polymeric material having commercial application. Polymer blending is economically more attractive way than copolymerization. Copolymerization is not so easy, and it is costly also to develop new polymeric material with improved performance. And another advantages of polymer blending is we can improve the processability of the polymer system. For example, you know that polyphenylene oxide, PPO, it is abbreviated as PPO, having the glass transition temperature 210 degrees Celsius. And if you want, that polymer is processable only at a higher temperature. So we want to process that material easily processable by blending with the polypropylene or polystyrene. For example, polystyrene glass transition temperature is 100 degrees Celsius. So when we mix polyphenylene oxide with the polystyrene, we can reduce the temperature. That meaning we can easily process that material. That is the advantages of polymer blending. Can you hear me, my sounds?
Yes,
Yes.
it's audible, sir.
Okay.
Okay.
Then polymer blends. There are different types of polymer blends. That meaning thermoplastic polymer blends are there. For example, when we mix polypropylene with polystyrene, that is a thermoplastic blends. Thermoplastic rubber blend. For example, SBR or natural rubber is mixed with polypropylene. That type of rubbers are called thermoplastic rubber blends. Then thermoplastic thermosetting blends. That is by mixing, for polypropylene with bakelite or urea formaldehyde, or polystyrene with melamine formaldehyde. Such systems are called thermoplastic thermosetting blends. And the other one is rubber thermosetting blends. If we mix natural rubber or nitrile rubber or SBR by mixing with bakelite or melamine formaldehyde, that type of rubbers are rubber thermosetting blends. Then sometimes we have to prepare polymer with a functional group or value added filler such we can say that they are also polymer blends. Then here I am going to discuss what are the different methods for polymer blending. Different methods used for the preparation of polymer blends are solution blending. This I will explain later details. Another blending method is melt mixing method, then simple mechanical mixing method, lattice mixing, and partial block or graft copolymerization by mixing with by introducing partial block or graft copolymerization techniques, or the preparation of interpenetrating polymer networks, IPN, that is called IPN system. So I am details how solution blending. Also, you for example, most of them are your college also this time due to this pandemic situation, the project works are under printing, right?
Yes, sir.
So
Yes.
you can simply use here also. I have to suggest some simple works also for you. By simple, this method by solution blending is an easy method for the preparation of polymer blends on laboratory scale. That is by simply mixing. For example, if you bought polyvinyl alcohol, PVA, that is a water-soluble polymer, or polyvinyl pyrrolidone, that is also a water-soluble polymer. So what you have to done is you take any other waste material or some. I will show some of the interesting work in this system. So you take polyvinyl alcohol and add the filler and make it in a composite, and you have to study the FTIR, UV properties, and also some solubility, chemical resistance of that system. Here the solution blending. Solution blending is so easily take the polymer and dissolve it in a suitable solvent, and and we add the filler or any other polymer into that system, and stirred well, and finally after for some time, and finally the blend is separated by simple precipitation or evaporation of the solvent. For example, if you blend polyethylene, for example, polyethylene plastic carrier bag, waste carrier baggage you can take, and you can put it in a solvent like toluene or xylene. It is soluble. Slightly heating, when it is slightly heating, it is easily soluble. And if you take thermocol, you know that thermocol is a polystyrene, and that is also a waste material that can be seen in everywhere in the earth, waste as a waste material. And you simply put together this in a suitable solvent like toluene or xylene, and you can prepare an easy blend. And how you can separate that blend? The simple way by precipitation of that one. By precipitation is carried out by adding alcohol to that system, so then it is easily precipitated out. Or other method is just by evaporation, evaporating that solvent. Final after evaporating all the solvent, you will get the blend system. During this time also you can ask questions during this time also, any doubts or anything, okay? And no problem, I have no problem, you can ask any, because after finishing all this you may not remember all these things, so you can ask some question in between this time also.
Sir, excuse me, sir.
Okay.
You mentioned a solvent for this blend. What
Yes.
was that solvent?
Xylene or toluene is easy.
Okay.
When you take a polyethylene bag, waste polyethylene, any other any other plastic materials like PET, polyethylene terephthalate, PET bottles are there. If you cut it into small pieces, that PET bottles, and put it in a, don't cut it, or simply just cut it and put it in a solvent like toluene or xylene, it is easily soluble. And After that, you can prepare another, you can mix another polymer into that system and add some filler like fly ash, fly ash as a waste filler, fly ash, or any other marble powder, then whatever, this wood powder like arkapodi, marathinde podi. You can add those things into that system, and you can prepare some biocomposites from thermoplastic biocomposite system for that, and you can study. But the major disadvantages of this system is what? The solvent, that separation of solvent is a tedious process. Meaning, when we evaporate, for example, toluene and xylene, not so much, but when some carcinogenic, for example, some of the polymers are dissolved in dimethyl sulfoxide, DMSO or THF evaporation, and that evaporation, meaning the solvent coming out, is not good for our health and environment. That is the disadvantages of solution blending. But for your MSc or BSc projects work, this is so easy method that you can use. Water is used as a solvent, or any other like toluene, benzene. Benzene is harmful. Toluene, xylene, or DMS or DMF, and so on. Okay, then another mixing is mixing. It is not so easy for your lab, because it needs a Brabender plastic coater or an internal mixer which can have the capacity to supply heat into that system. But melt blending is compatible with industrial process. It is simply extrusion process, injection molding process. Melt blending of polyphenol ether, polystyrene, and curable resins are, and this type of and which is used as an adhesive in electronic applications also, this polymer. And these are prepared by simple melt mixing. Or melt mixing is environmentally due to the absence of organic solvent compared to solution. But the major drawback of this melt mixing is when the polymer is melted at higher temperature, quite naturally conformational entropy change will take place, and that will affect the mechanical properties of that system. That is the disadvantages of melt blending. And mechanical mixing. This is the cheapest one, and which is also carried out with the help of a two-roll mixing mill or internal mixer, without another advantages, without using any organic solvent. MSc students two-roll mixing mill കണ്ടിട്ടുണ്ടോ?
കണ്ടിട്ടുണ്ട് സർ, അവർ ഇന്റേൺഷിപ്പ് ചെയ്തിട്ടുണ്ട്.
Okay. They know very well. അപ്പം ഇതിനകത്തും നമ്മളിപ്പം SBR, when we prepare SBR mixing of, when we make a SBR natural rubber blend, it is a blend that is a compatible blend. I will discuss that one later. But blending can be carried out, this NR or NBR or SBR, any other elastomer, that can be mixed with the help of a two-roll mixing mill, which is more convenient method and fast and simple method for blending polymers. And there is no organic solvent used in this system. Another one is latex mixing, which can be carried out by using a ball milling or colloidal mill. That is the ball milling means small different size balls have different sizes used in a cylindrical vessel. And this lattice, when we take the lattice into, for example, SBR lattice or NR lattice, natural rubber lattice, or chloroprene lattice, these are available in lattice form or emulsion form, and these are carried out in a lattice mixing process using ball milling or colloidal mill. And another method is block or graft copolymerization. Grafting. Do you know how to graft a polymer? പോളിമറൈസേഷൻ പോളിമർ നിങ്ങളുടെ സിലബസിൽ ഇതിലുള്ള പഠിക്കാനുള്ളതാണോ MSc കാർക്ക്? ഒരുപാട് ശബ്ദം കേൾക്കുന്നു. ഹലോ, ഇതൊന്ന് മ്യൂട്ട് ചെയ്യണോ? ഓക്കെ. ബ്ലോക്ക് ഓർ ഗ്രാഫ്റ്റ് കോപോളിമറൈസേഷൻ. ഗ്രാഫ്റ്റിംഗ് നിങ്ങൾക്ക് പോളിമർ നിങ്ങൾ പഠിക്കുന്നുണ്ടോ കുട്ടികളെ MScക്ക്? ഹലോ, can you hear my sound? പോളിമർ ഓക്കെ. ഗ്രാഫ്റ്റ് കോപോളിമറൈസേഷൻ അല്ലെങ്കിൽ ഗ്രാഫ്റ്റിംഗ് ഒക്കെ പഠിക്കാറുണ്ടോ?
ഒരു ബേസിക് ഐഡിയ ഉണ്ട്, ബേസിക് ഐഡിയ വരുന്നുണ്ട്.
ഓക്കെ ഓക്കെ. അപ്പോൾ അത് പ്യുവർ പോളിമർ ആണോ? നിങ്ങൾ പോളിമർ ആണോ സാധാ ഏത് കെമിസ്ട്രിയാണ്? ജനറൽ
കെമിസ്ട്രിയാണ് ഞങ്ങള്.
ഓക്കെ ഓക്കെ. അപ്പൊ അതൊന്നും അറിയാൻ വേണ്ട. അപ്പൊ
അറ്റൻഡ് ചെയ്യുന്നുണ്ടാവും ചിലപ്പോ വേറെ കോളേജിൽ.
ഓക്കെ ഓക്കെ. So blending can be carried out by block or graft copolymerization. Grafting is an attractive way to introduce a different functional group into a polymer. For example, we can convert polypropylene. Polypropylene, it is a non-polar polymer which can be converted into a polar polymer by simple grafting. Simple way, take polypropylene, take polyethylene, and which is dissolved in suitable solvent like xylene, and you add 0.2% of dicomyl peroxide as a initiator to that system, and heat that system. And what you want to graft? For example, you can graft maleic anhydride. Maleic anhydride having a polar functionality is there. Maleic anhydride graft polypropylene can be prepared. So it's simple. Take polypropylene in a suitable solvent, or dissolve polypropylene in a suitable solvent, add 0.2% dicomyl peroxide, followed by adding the grafting, which one you want to graft. For example, if you want to graft maleic anhydride into the system, maleic anhydride is just added and carried out that polymerization. That is called a graft techniques. So you can graft any system. For example, if you want to graft acrylamide into polypropylene, easy. Take our acrylamide into polyethylene. You take polyethylene, dissolve in benzene or toluene or xylene that into any solvent, and add 0.2% peroxide initiator, dicomyl peroxide or benzoyl peroxide is used as an initiator. That is benzoyl peroxide that is used as a free radical initiator in simple free radical polymerization system. And add benzoyl peroxide into that system, add acrylamide 0.3 or 0.4% like that. You add acrylamide into that system, and you can prepare polypropylene graft acrylamide. So easy way. Block copolymers, which can be prepared by living polymerization. That anionic polymerization you can prepare. Anionic polymerization are called living polymerization because there is no termination in that system. So you can prepare polystyrene block, acrylonitrile. You can polystyrene block, acrylonitrile block, styrene block, butadiene. So you can prepare a long chain compound by living polymerization techniques. And nitroxide mediated polymerization, these are advanced polymerization techniques for preparing polymers for high advanced engineering application. Another one is ATRP, atom transfer radical polymerization techniques. This is also one of the modified form of free radical polymerization. And another one is RAFT, reversible addition fragmentation chain transfer polymerization also. These are the method to prepare block copolymer. And another one I discussed earlier, the interpenetrating polymer networks. And IPN, it is interpenetrating polymer is called abbreviated as IPN. And IPN is defined as a blend of two or more polymers in a network form, at least one of which is synthesized or cross-linked in presence of other. Use of monomers as a solvent for another component, and then polymerization, interpenetrating network. An IPN can distinguish from polymer blends or block or graft in two ways. IPN just swell but dissolve in solvent, but not dissolve in solvents. And it have creep and flow properties are suppressed in that system also. And then I go to the different methods, characterization method, how we can characterize this polymer blend system. For example, when you blend polyvinyl alcohol and polyvinyl pyrrolidone. Polyvinyl pyrrolidone is actually a pyrrole ring system, and that pyrrole is double bond is absent. And then in that pyrrolidine system, second position carbonyl group is attached, and in that to that nitrogen CH2 group is that is polyvinyl pyrrolidone and polyvinyl alcohol that you know. And when we mix together, what are the possible reactions that taking place in that system that can be carried out? But there should be an effective hydrogen bonding, because polyvinyl alcohol containing OH group and this polyvinyl pyrrolidone containing carbonyl group. So there definitely a carbonyl group and these O groups have some interactions, and those interactions can be identified by using FTIR or Raman spectroscopy, small angle neutron scattering method, or neutron reflectivity. NMR techniques, nuclear magnetic resonance technique is used. Scanning electron microscopy is used to identify the formation of blends. AFM, atomic force microscopy, transition electron microscopy, fluorescence microscopy, and differential scanning calorimetry techniques are the most common techniques to identify whether the polymer, whether there is any interaction in that polymer blends, or whether the polymer is formed or not. That can be easily adjusted by these techniques. Then types of polymer blends. There are different types of mainly miscible polymer blend and immiscible polymer blend. And another are there. And some other categories are there. Miscible polymer blends. Polymer blends homogeneous down to molecular level. It is a single phase structure, has the properties of average values between the values of its properties of components, and these blends show a single TG. For example, if you mix polypropylene and if you mix with PMMA, it will not mix soluble. It is called an immiscible blend. That meaning, if you mix, for example, polystyrene, glass transition temperature is 100 degrees Celsius. And if you mix polystyrene with nitrile rubber, thermoplastic rubber blend system, nitrile rubber having glass transition temperature minus 45 degrees. And when you mix together, as we all know that polystyrene is a non-polar polymer and nitrile rubber is a polar polymer, so that polymer blend is not effective interaction because of the absence of functional group in polystyrene. So such type of polymers are called immiscible polymer blend. And for example, if you mix PVC, polyvinyl chloride, with PMMA, both the polymers are polar polymers, and they are somewhat miscible. And when you mix at a particular ratio, it shows a single TG. Both the components have two different TG, but when you mix together, it show a single TG. And if a polymer blend shows single TG, we can say that it is a miscible polymer blend. Then another one is immiscible polymer blend. A blend exhibits more than two phases that I already mentioned. Polystyrene is a non-polar matrix and NBr is a polar matrix. So it has two different phases, and usually it has two different TGs. Since the two components are phase separate, that is miscible polymer blend, immiscible polymer blends. Then homologous polymer blend. Homologous polymer blends meaning mixture of two or more fractions of same polymer with each has different molecular weight distribution. Homologous polymer blend system, different. For example, homologous system when you mix polystyrene with polypropylene, that type we can say that is a type of a homologous polymer system because both are non-polar system. Polymer alloys are another class of polymer blends. They are immiscible compatibilized polymer blend with modified interface and morphology. You know that ABS is acrylonitrile butadiene styrene, which is an alloy of the copolymer of acrylonitrile butadiene and styrene system. Then compatible polymer blend. An immiscible polymer blend is called compatible if it is useful blend wherein inhomogeneity caused by different phases is small scale. Blends which are miscible in a certain useful range of composition and temperature, but immiscible in others. Most compatible blends are immiscible and can be made compatible by using compatibilizers. Compatibilization techniques that I will discuss later. Okay, this is compatibilization. If there is a strong interaction between the phases, then the polymer blend will be miscible in nature. Interfacial tension is zero. That meaning there is no there is an effective interaction between these two component system. That is in that system interfacial tension become zero, and such a system is called a miscible blend. Large interfacial tensions. For example, if we mix SBr with chloroprene rubber, one is polar and another one is non-polar. SBr is a non-polar polymer, chloroprene is a polar rubber. When we mix together, the large interfacial tension will create, which leads to a phase separation. And these phase separated particles are perhaps undergoing coalescence. And this will result in an increased particle size, which in turn decrease the mechanical properties. For example, the tensile strength of chloroprene rubber is nearly 21 megapascal, and SBr is only 3 megapascal. And what happened when we mix this together, the tensile strength of this blend will come around 10 megapascal. So that meaning that blend, the properties of chloroprene rubber, that strength of chloroprene rubber is much more reduced by blending. So that is because of the increased particle size and large interfacial tensions created in that system. The interfacial tension between these two systems can be improved by adding interfacial agent known as compatibilizers. These are generally molecules which have hydrophobic or hydrophilic moieties that can be aligned along the interfaces between the two polymer phases, causing the interfacial tension to be reduced and compatibility of the polymer blends to be increased. Compatibility results in a reduction of displacer size and enhanced phase stability and increase the mechanical properties. The role of compatibilizer is the symbol, the role of phase transfer catalyst. You know that when you mix, for example, when you mix a chloroform with sodium hydroxide, one chloroform is an organic solvent, and sodium hydroxide, aqueous sodium hydroxide is an aqueous medium. So you know that you have already studied that one. Chloroform, when chloroform reacts with sodium hydroxide, it forms a dichlorocarbon, CCl2, that you studied in your organic classes. And that reaction is when you mix a double bond. For example, if you add a butadiene system into that, polybutadiene or SBR rubber into, take SBR rubber, which is dissolved in a solvent, add chloroform and sodium hydroxide, the dichlorocarbene modified SBR should be formed. But the problem is the yield of that reaction is very poor, because one is organic medium and another one is aqueous medium. So in order to improve the yield of that system, you are adding a phase transfer catalyst. The same way, you are adding an external agent that is called cometabolizer, which is same as that of the phase transfer catalyst. And what is the role of phase transfer catalyst? It extracts the aqueous phase into organic phase, or organic phase into an aqueous phase. That means simple സിമ്പിൾ ഒരു പുഴയ്ക്ക് കുറുകെ ഒരു പുഴയുണ്ടെങ്കിൽ അക്കരെ നിൽക്കുന്ന ആൾക്കാർക്ക് ഇക്കരെ നിൽക്കുന്ന ആൾക്കാർക്ക് തമ്മിൽ ഒരു ഇന്ററാക്ഷൻസ് ഇല്ല. അപ്പൊ നമുക്ക് പറയാൻ പറ്റും they are immiscible system. So they can be made miscible or they can be made compatible system by using a bridge. അപ്പോൾ അക്കരെയുള്ള ആൾക്കാർ ഒരു ബ്രിഡ്ജ് ഉണ്ടാക്കി കഴിഞ്ഞാൽ അക്കരെയുള്ള ആൾക്കാർക്ക് ഇക്കരെ വരാനും പറ്റും, ഇക്കരെ നിന്ന് ആൾക്കാർക്ക് അക്കരയ്ക്ക് പോകാൻ പറ്റും. So that is the role of cometabolizer. That is the role of phase transfer catalyst also doing in organic aqueous layer medium. Okay, and then this what some multifunctional cometabolizer can be prepared. This is, we can prepare low density polyethylene. Linear low density polyethylene is one of the form of polyethylene. And here also I given low density polyethylene samples are dissolved in xylene at 130 degrees Celsius and then reacted with various percentage of maleic anhydride in presence of dicomyl peroxide. This I already mentioned earlier. We can convert low density polyethylene, that is a non-polar system, into a polar system by grafting or by attaching maleic anhydride into that maleic anhydride graft low density polyethylene. Or multi-system, we can use maleic, instead of maleic anhydride we can use methyl methacrylate. So you can methyl methacrylate graft low density polyethylene can be prepared. Or you can prepare vinyl acetate into that system. You can add ester group. If you want to prepare or if you want to introduce an ester group into a non-polar LDP, it is simple way by graft polymerizer that I mentioned earlier. And into this low density maleic anhydride graft system, we can add another functional group such as vinyl acetate into this system. This maleic anhydride graft LDP, maleic anhydride graft LDP was again mixed with vinyl acetate or methyl methacrylate monomer and add dicomyl peroxide 0.2%. You can prepare multifunctional cometabolites. So one is maleic anhydride group. Another one is you can prepare ester group or ester group or any other carbonyl groups. You can add, and it can be used as a multifunctional cometabolizer in system. Then factors affecting immiscibility, polarity. Polymers that have similar in structure, have similar polarity, are less likely to repel each other, and that meaning there is some interaction between this system that can form miscible blend. Specific group interaction, such as hydrogen bonding, acid base or charge transfer or dipole-dipole interaction or donor-acceptor attraction, they can form miscibility. Then another, molecular weight. Low molecular weight permit greater penetration or mixing and therefore greater gain of entropy, which favors miscibility. More surprisingly, polymers of similar molecule weight are generally miscible, while polymers of very different molecules may be miscible. That depends upon the condition, composition, how they are mixing. 1:2 or 1:3 or 1. That depends upon the ratio, blend ratio. Finally that is given blend ratio. And another one is when you prepare when a polymer is crystallized during the blending itself, that is also good. But it is not so easy. When a polymer crystallizes, it forms two different systems. If both polymer in a blend crystallizes, they will usually form two separate crystalline phases, and it is quite rare for these two polymers to co-crystallize in a single crystalline polymer. Blend ratio is an important factor. For example, generally polymers are blended in this ratio 70-30, 50-50, or 30-70. For example, if you want to prepare NR and SBR blend, you can prepare 100 NR one system, 100 bar 0 system, then 70 NR and 30 SBR, then another combination 50-50 ratio, 50 NBR, 50 NR and 50 SBR, and another one is 30 natural rubber and 70 SBR. That way you can prepare, and finally 0 bar 100, that meaning NBR 100 NR 0. And that maybe at a particular blend ratio, the polymer become miscible, or that it depends upon the experimental condition that we are using. So now I am going to these are the simple basic things that you know about, that you know about the polymer blends. So here we have prepared, recently we have prepared a chlorinated nitrile rubber and chlorinated NBR blends. For example, nitrile rubber and EPDM rubber, that you know, ethylene propylene diene monomer rubber, that polymer is a immiscible polymer, because NBR is a polar polymer and EPDM is a non-polar polymer. When we mix together, it is not compatible, it is an immiscible blend. So here we prepare a miscible polymer blend system by simple chlorination on nitrile rubber. Nitrile rubber we have chlorinated, and ethylene propylene rubber we have chlorinated that system, and we prepare a master batch techniques for this blend system. This is simply done by using a 2-roll mill mixing technique, and the different ratios like 70-30, 50-50, and 30-70 of the blend ratio that we are prepared for that system. And the dichromail peroxide is used as a vulcanizing agent for cross-linking these two polymer systems. And this is recently published in Polymer Testing Journal, Elsewhere Journal, November or August 2020, I think. And another one is regarding about this, how this catalyst, we have know about XRD, some term, these are used for the catalyzation of polymer blends. Here you can see the, how the XRD gives an idea about this blend. You can clearly see that this chlorinated NBR have a that blue color have a broad XRD peak, and this when we mix this ratio, you can see that green color 50-50 blend that into that system, this is become too narrow. That meaning this is some idea about that 50-50 blend may have some good properties, and some vague idea about the mechanical properties will be obtained from this SRD system. X-ray diffraction pattern system, and this is some morphology, and you can see that the first one is 70-30 system. You can see some bump type, some humping, or some projections are seen in that system. Whereas in the case of 50-50 blend ratio B, there is a uniform morphology, which is a clear indication about the formation of a miscible polymer blend system, and the ratio this morphology becomes slightly changed into an agglomerated or some irregular structure at 30-70 blend. So this means that 50-50 blend is good for this system. And this is a differential scanning calorimetry studies, that meaning glass transition temperature. Glass transition temperature meaning the temperature at which the polymer become hard this rubber become hard at a particular temperature. That can be, it can be easily broken at glass transition temperature. And you can, here you can see that a single glass transition temperature is obtained. This is a clear indication for the visible polymeric applied system. These are some mechanical properties that we have studied in that system. And you can see that the tensile strength is, maximum tensile strength is obtained for 50-50 blend ratio. And you know that chlorinated NBR is tensile strength is only 9, whereas chlorinated EPDM is 17.5. And when we mix together, that 50-50 ratio that have tensile strength much higher than that of the much higher than that among the whole system. Similar observation is observed for tear strength. Tensile strength that you know, tear strength meaning how it become that polymer become teared. And the tear strength also shows the highest value at 50-50 blended. Hardness is also that depends upon the slight changes. Heat buildup, that meaning the generation of heat in that system is studies. Abrasion loss, how that if you prepare a polymer which show how much it will be the abrasion loss, and abrasion loss is lesser for 50-50 blend system, which means that there is an efficient interfacial interaction or strong interaction between the chlorinated NBR and the chlorinated EPDM. That is the reason for higher abrasion resistance value. Well, and another you can see limiting oxygen, last one LOI%, limiting oxygen, that is meaning flame resistance of that material. That is by burning the substance in presence in a mixture of nitrogen and oxygen atmosphere, and when we reduce the content of oxygen, you know that substances are, rubbers are burned in presence of oxygen only. When you reduce the oxygen, the flame will cut off. And you can see that the flame resistance is also, that depends upon the chlorinated the polymer, chlorine content of that system, because chlorinated polymers have the property of intumescence effect. You know that when you burn polyvinyl chloride or PVC pipe, when you burn, it will never burn. It is just some smoke will coming out. So PVC, that property have a intumescence effect. That meaning when we burn a polymer, a char is coming out, and that protects further burning of that substance. And that phenomena is called intumescence effect, that maybe you know. So chlorinated polymers have this intumescence effect or flame resistance system. And that is the reason my chloroprin rubber is used as a flame resistant coating material in fire extinguisher or fire resistant applications also. And chloroprin lattice is also used as a coating for painting, weather resistant or fire resistant coatings are made from chlorinated elastomers. And here it is a good properties obtained for this novel blends. This is the oil resistance. Oil resistance is an important parameter for the fabrication of rubber products in sealing applications of gearboxes, housing, to prevent the leakage of liquids. And here also chlorinated NBR, you know that NBR is mainly used for oil seals or oil bearings or oil seals application. If you prepare a gloves from natural rubber and when you put it in an oil, the gloves will damage easily because this oil is penetrate into that system, and the gloves, the performance of the gloves, that meaning the gloves will easily damage. But when you prepare a gloves from nitrile rubber, that can prevent the penetration of oil into that system, and hence the oil resistance application nitrile rubber gloves are using, or nitrile rubber seals are using. And we have already published that chlorination, chlorinated nitrile rubber have very high oil resistance and nitrile rubber. Now, at the same time, nitrile rubber is easily flammable one, but our prepared chlorinated nitrile in this system that do not show flame, that is not flammable easily. That means it have very good flame resistance. It have very high oil resistance than NBR, so it can be used as a substitute. This chlorinated NBR can be used as a substitute for nitrile rubber. Then I move to some biodegradable blends that you can prepare in your lab also. The demand for biodegradable polymers become an urgent and necessary issue with a view to drastic reduction in petroleum-based product and other corresponding emissions of environmental pollutants. Among the biodegradable polymer, water-soluble polymers are important from industrial point of view. For example, polyvinyl alcohol, polyvinyl pyrrolidone blends. When you prepare these blends, it is some interesting physical properties are arising, which is due to the interaction between the hydroxyl group of PV and the carbonyl group of PVP. That meaning, more specifically, the intermolecular interaction between the hydroxyl group or carbonyl group of the side chains of polymer leads to a strong hydrogen bond. So this is the simple work by an MSc student from Valanchery, MES Valanchery. No, this is from but on an MSc student project. Yes, MS Valanchery student. Yes, I think she simply take polyvinyl alcohol, polyvinyl pyrrolidone, and pumice composites. You know that pumice is a lightweight, highly porous volcanic glass. This selenol groups, plenty of selenol group formed during the explosive eruptions, and it has very high thermal stability, high surface area with various polar functional group. So here we simply prepare PVA, PVP, 50-50 blend ratio we prepare in, that is used in water, and thus stir the solution 70 degrees, and various percentage of pumice, 5 to 25% of pumice particle is added and stirred the mixture for 2 hours. The solution was then transferred into a petri dish and dried in the oven at 60 degrees Celsius for 3 days. The film was then filled from petri dish for further studies. So this is the FTIR spectra of that polymeric system, and you can see that PVA, PVP that show a very broad peak at 3,500 centimeter inwards, and you can see that when you mix this pumice stone, this broadness of that system is much reduced. This is a clear indication for the interaction of pumice particle with the blend segments. Can you audible? Okay.
Yes, sir. Audible.
Okay. Then another one, this XRD. When that student take the XRD of PVA pumice composite, and that XRD, we can say that there is a absence of peak and some reduction in the amorphous region, and with a strong intensity peak is observed for pumice stone system. And thermal stability of the PVA PVP blend is much improved by adding. This is the thermogravimetric analysis, TGA analysis, shows that the thermal stability of that system is increased with increasing the loading of that pumice particles. Another biopolymer that we prepare for, this is also an MSc project from St. Mary's College, Wayanad, and that earlier paper was published in Journal of Thermal Analysis and Calorimetry, and this paper was published in Polymer Composite. This is simple, an MSc project work. Here what I have done is, by mixing this pumice particle into a polyvinyl alcohol cashew tree gum. That is the cashew tree gum. Natural gums are obtained from the plants. which have widespread of industrial applications because they can form film forming ability, or they can form viscous solution, gel or emulsifying. They are used as emulsifying agent. Cashew tree gum is one of the major byproduct of cashew industry, and hence demanding for industrial application. It also containing many polysaccharides such as galactose, glucose, arabinose, ramos, etc. But however, it have poor mechanical strength. And we know that polyvinyl alcohol have very good mechanical strength. Here, what I done is, by mixing this polyvinyl alcohol with the cashew tree gum, and that blend property was further improved by using pumice particle. This pumice stone that you may familiar with this aquarium. That aquarium in a fish, that aquarium pumice stone are put in that system, aquarium system. Here, these blends are prepared by simple solution casting technique. PVA, cashew gum solution separately dissolved in water. PVA is dissolved in water, cashew gum is dissolved in water, mixed together 50-50 blend ratio, and to that system we have added different concentration, different percentage of pumice system, and stirred the solution to become a homogeneous, and subsequently this solution is transferred into a petri dish and dried it in hot air oven for 45 degrees 72 hours. Here we study. And also, this is the FTIR system, and here also the here the broadness of PVA CTG blend. Here a broadness is increases along with the presence of the peak of pumice particle is also visible in this PVA CTG system. This is the XRD of that system. By adding the pumice strand, we can reduce the amorphous peak of that polyvinyl alcohol and get the formation of pumice particle, or the interaction of pumice particle in this from this XRD is clearly visible by seeing this graph. This is a some image, and some image of PVA CTG is left one A. And when we add pumice stone, we can see that some of the particles, particles are seen. And when the loading becomes higher, 15 weight percentage, these pumice particles are agglomerated. Then our next section, polymer blend nanocomposite. The mechanical properties of polymer blends are improved by adding nano fillers. The addition of reinforcing or functional filling expected to overcome the disadvantage of polymer blends. Blend composites are heterogeneous system wherein the polymers are compound with micron or nano size particle to impart high strength electrical, and polymer blend nanocomposite have attracted extensive interest on the fabrication of advanced engineering material with good mechanical, electrical and optical properties. The mechanical, thermal and electrical properties of polymer or biopolymer blends can further be improved by mixing metal or metal oxide nanoparticle with the blend matrix. This hydroxyapatite nanoparticle reinforced chlorinated NBR. This is another paper that we have, then the blend that I mentioned earlier. Here we add a hydroxy nanoparticle into this chlorinated NBR and chlorinated EPDM blend. This is carried out in a 2-roll mill mixing technique. And here we use 50-50 blend for that system because 50-50 blend shows the highest mechanical property. That is the reason why we took 50-50 system. DCP is used as a vulcanizing agent. And this is the FTIR spectra of this hydroxyapatite HA. And when we add hydroxyapatite into that system, this OH group is coming in these polymer blends with the IR peak of HA in this blend system. This is the XRD of that system. XRD, we can see that 50-50 blend show a broad peak, and by the introduction of hydroxyapatite nanoparticle, the hydroxyapatite peaks are visible at this 5 PHR and 10 PHR HF system. This is the some morphology, and you can see that hydroxyapatite nanoparticle can be clearly visible in this system. At higher loading, these nanoparticles are slightly agglomerated. This is the TEM images. We can see that some spherically shaped particles are visible at lower loading. However, the size of the particle become elongated and become agglomerated at a higher loading of chlorinated EPDM, chlorinated NBr, HI, and composite. This is the pure characteristics of these properties. You can see that the vulcanization time is reducing with the addition of this hydroxyapatite nanoparticle. So vulcanization time reducing meaning it is more economic, and the product that we can prepare from this is good for because the time, it is a time saving factor, and also vulcanization time can be reduced. This is the mechanical properties of that system, and we can see that this is N3, 5, 7, 10 are the various loading of that system, and we can see that the tensile strength become maximum at 7 weight percentage, BN7. And most of the tear strength also that same properties, abrasion loss, heat buildup, resilience also shows this similar trend, that meaning 7% loading. Then another work, this is also an MSc. That earlier work is a PhD work of my student. This is an MSc project work that was published in polymer composite, copper sulfide nanoparticle reinforced PVA PUP system. Here symbol PVA PUP dissolved in water, and to that we have adding different loading of copper sulfide nanoparticle into that system. This is the schematic representation, how these copper nanoparticles are incorporating between these two polyvinyl alcohol, polyvinyl pyrrolidine, in between how these nanoparticles are this SDS is used to avoid the agglomeration of nanoparticle in this system. FTIR spectra, copper sulfide nanoparticle incorporate PVA PUP blend shows, you can see that this copper sulfide nanoparticles, the copper sulfide nanoparticle shows the peak, copper CUS peak at 614, and it is slightly shifted to 604 in PVA PUP copper sulfide system. This means that the nanoparticles are, copper sulfide nanoparticles are efficiently interpenetrated or efficiently incorporated into this PVA PUP blend. This is the XRD of CUS nanoparticle in PVP, and here also you can see that PVA PUP shows the presence of the crystalline peak of copper sulfide in that system. This is the TEM images. And the TEM images, you can see that these copper sulfide nanoparticles are some spherically or hemispherical particles are seen at this lower loading. At the higher loading, these particles become agglomerated. This is the thermogravimetric analysis, and thermogravimetric analysis which gives an idea about the thermal stability of that system, and thermal stability is increased with increasing the loading of this copper sulfide. We know that copper sulfide metal particles have very high thermal stability, so it can impart better thermal stability into PVP system. This is the AC conductivity. You know, copper is a very good conducting material, so it can impart conductivity to this PVA PUP. Conductivity can be improved or imparted into PVA PUP system. This also work from SN College in article from MSc students project work that is published in Journal of Polymers and Environment. She simply take PVA or PVP blend with a silver doped zinc oxide nanocomposite. 50-50 PVA PP were dissolved in water. To that 2 to 15% silver doped zinc oxide was added into that system and stirred the mixture for 3 hours, followed by ultrasonication and the solute, and tried it for 2 days. And this is the FTIR spectra. FTIR shows the characteristics, properties or characteristic peaks of copper sulfide in PVA PUP system. And this XRD system also PVA PEP system. We can see the copper sulfide, the XRD crystalline peaks of copper sulfide are visible in this PVA PEP system. This is another evidences that silver doped zinc oxide are efficiently interact with the PVA PEP system. This is the some images, and some images show the presence of silver doped zinc oxide nanoparticle. The differential scanning calorimetry, and this is the glass transition temperature is slightly increases with the increasing the loading of silver doped zinc oxide. This is due to because this nanoparticle can the addition of the loading of nanoparticle resist the movement of the polymer chain, which result in higher glass transition temperature. This is also another work by an MSc project student from Ramesan College in Natia. She simply take chitin, cashew gum as a biopolymer system. To that we have adding magnetite Fe3O4 nanoparticle into that system. Here we prepare chitin in an acid, acetic acid dissolved in acetic acid solution, and cashew gum in water. Mix this solution together, and we are adding different content of 3 to 15% Fe3O4 nanoparticle into our system. SDS is added to this system and ultrasonicated for 15 minutes. And that this SDS is added to prevent the agglomeration of nanoparticle into this polymer system. And this mixture is again ultrasonicated and finally stirred to get a homogeneous solution for 45 to get a homogeneous solution. And finally the compound is product is dried in vacuum at 45 degrees Celsius for 12 hours. This is the FTIR spectra. FTIR spectra shows the presence of magnetite nanoparticle in this system. Some images of this chitin cashew gum. Some images shows the presence of magnetite nanoparticle into that system. XRD of chitin cashew gum shows this nanoparticle system. Here also chitin cashew gum, this thermal stability is greatly improved by the addition of iron oxide nanoparticle into this biopolymer system. This is silver doped zinc oxide as a nanofiller for the development of biopolymer nanocomposite from chitin and cashew gum. This I earlier mentioned, I think. Chitin cashew. This is magnetite. Okay, this is another MSc project work by similar work, chitin, cashew gum. The matrix is there, magnetite. Here is silver doped zinc oxide. This is an MSc project work which is published in Journal of Polymer Research. One Springer journal, I can't remember that one. This is published in more than 2 impact factor journal, I think. And also here also the similar way that we prepare, only the variation is used 3 to 15% is silver doped zinc oxide into that system. The mixture was vigorously stirred for this system, and finally the tried at 45 degrees Celsius for 12 hours. This is the UV spectra that we have taken, and UV spectra you can see that this absorbance of the peak decreases with the loading of nanoparticle, and the 7 weight percentage shows the lower the intensity of that, meaning the peak height is minimum for this 7 or 8%, which means that this 7 or 8% is having good properties. This is the FTIR spectra. FTIR spectra support the formation of silver doped zinc oxide in cashew gum. This is the XRD pattern, and this is the TEM images that that project student taken, and this TEM images also supported the formation of zinc oxide nanoparticle in chitin cashew gum blend system. This is a DSC, and DSC also similarly like earlier work. the glass transition temperature of the blend increases with increasing the loading of nanoparticle, because more will the loading of nanoparticle, more will be the less will be the rust movement of the chain. That will definitely allow, we can say that the rigidity of the system increases. That will leads to higher glass transition temperature. This is the dielectric constant that we have studied. Dielectric constant is maximum for sound weight percentage sample. This is another PhD student's work. What he have done here is magnetite is this is an in situ polymerization of polyvinyl alcohol indole monomer with magnetite. In situ polymerization. I think the time is 5 more minutes, right?
Yes, sir. Time.
Okay, I will complete this system. Am I winding up?
So okay, sir. You can.
Polyvinyl alcohol magnetite blend nanocomposite is synthesized by an in situ polymerization techniques. This is a PhD work. I am not going this system. This is the some images, TGA studies, dielectric studies. And we can stop, I think. Can stop this. Any questions you can ask?
Hari, any questions from YouTube? No question. Okay.
നിങ്ങൾക്ക് ബോറടിച്ചിട്ടുണ്ടാകും. കാരണം എന്താ, 1 മണിക്കൂർ നമ്മൾ 12 മണിക്ക് തീരേണ്ടത് ഇപ്പൊ 12:30 അത് ഞാൻ പിന്നെ
കുറച്ച് തുടങ്ങാൻ വൈകിയപ്പോ ഒരു 10 മിനിറ്റ് അവിടെ മിസ്സായിട്ടുണ്ടായിരുന്നു.
അതാണ്
ടൈം ലിമിറ്റിൽ നിന്നിട്ടുണ്ട്, പക്ഷെ തുടങ്ങാൻ വൈകിയത് കൊണ്ടാണ് 20 മിനിറ്റ് അവിടെ പോയിട്ടുണ്ട്.
അപ്പൊ നിങ്ങൾക്ക് ഞാനിപ്പോ ഈ വർക്ക് നിങ്ങൾക്ക് പറഞ്ഞതിന്റെ കൂടുതൽ ഞാൻ MSc പ്രോജക്റ്റ് ഞങ്ങളുടെ PhD സ്റ്റുഡൻസിന്റെ വർക്കുകളൊന്നും കാണിച്ചില്ല. കുറെ ഉണ്ട് ബ്ലെൻഡ് കോമ്പോസിറ്റ്. പക്ഷെ ഞാനിപ്പോ ഇവിടെ കാണിച്ചത് മുഴുവനും MSc പ്രോജക്റ്റുകാരുടെ വർക്ക് പബ്ലിഷ് ചെയ്യാൻ പറ്റുന്ന സിമ്പിൾ ആയിട്ടുള്ള, വളരെ സിമ്പിൾ ആയിട്ടുള്ള വർക്കുകളായിരിക്കും. കാഷ്യൂ ഗം, അതുപോലെ നാച്ചുറൽ ഗം, അതേപോലെയുള്ള മറ്റേതെങ്കിലും ഇതായിട്ടുള്ള കാഷ്യൂ ഗം ഒക്കെ എടുത്തിട്ടോ, അല്ലെങ്കിൽ ഈവൻ എന്താ പറയാ, ഈ വേസ്റ്റ് മെറ്റീരിയൽ നിങ്ങൾക്ക് ഒരു ഫില്ലർ ആയിട്ട് ഉപയോഗിച്ചിട്ടുള്ള ഇതുപോലുള്ള പോളിവിനൈൽ ആൽക്കഹോളോ അല്ലെങ്കിൽ കാഷ്യൂ ഗം പോലത്തുള്ള സിസ്റ്റത്തിലൊക്കെ നിങ്ങൾക്ക് സ്റ്റഡി ചെയ്യാം.
MSc പ്രോജക്ട്സ് നമ്മൾ വേറെ ഇൻസ്റ്റിറ്റ്യൂട്ടിലൊക്കെ ചെയ്യാറുണ്ട്. PSCക്ക് നമ്മൾ ചെയ്യിച്ചിട്ടുണ്ട്, ഇതുപോലെ കോമ്പോസിറ്റ്സ് ചെയ്യിച്ചിട്ടുണ്ട്, ക്യാരക്ടറൈസേഷൻ സ്റ്റഡീസ് ഒക്കെ ചെറുതായിട്ടൊക്കെ ചെയ്യിച്ചിട്ടുണ്ട്. പക്ഷെ ഇപ്പൊ എനിക്ക് കുറച്ചും കൂടെ ഐഡിയ ആയിട്ടുണ്ട്. ഇപ്പൊ സാറിന്റെ ക്ലാസ് കഴിഞ്ഞപ്പോൾ കുറച്ചും കൂടെ ഐഡിയ ആയിട്ടുണ്ട്, കുറച്ചുകൂടെ നന്നായിട്ട് ചെയ്യിക്കാൻ പറ്റും.
ഇതേപോലെ FTIR, UV, DSC, TGA, SRB അങ്ങനെയൊക്കെ ഉള്ളത് എടുത്തു കഴിഞ്ഞാലേ ഒരു പേപ്പറും അതൊക്കെ നിങ്ങൾക്ക് അതൊരു പേപ്പറും ഒക്കെ ആക്കി മാറ്റാൻ പറ്റും. അപ്പൊ ഞാൻ ഇപ്പൊ ഒരു 10-18 ഇങ്ങനെ MSc പ്രോജക്റ്റ് പിള്ളേരുടെ ഇത് വർക്ക് പബ്ലിഷ് ചെയ്യാൻ കിടപ്പുണ്ട്. ഇതേപോലത്തെ വർക്കുകൾ സിമ്പിൾ ആയിട്ടുള്ള. ഞങ്ങൾ മറ്റേ മെഡിസിനൽ പ്ലാന്റിൽ നിന്നുള്ള എക്സ്ട്രാക്ട് എടുത്തിട്ട് ഈ ബ്ലെൻഡുകളിലേക്ക് ചേർത്തിട്ട് അതിന്റെ ആന്റി ബാക്ടീരിയൽ പ്രോപ്പർട്ടീസ് അങ്ങനെയുള്ളതൊക്കെ സ്റ്റഡി ചെയ്തിട്ടുണ്ട്.
ഇതിന്റെ ബയോഡിഗ്രേഡബിലിറ്റി സ്റ്റഡി ചെയ്യാന്
പറ്റും. ബയോഡിഗ്രേഡബിലിറ്റി സ്റ്റഡി ചെയ്യാൻ പറ്റും. ഇപ്പൊ ബയോഡിഗ്രേഡബിലിറ്റി ഒന്നുകിലും നമുക്ക് സോയിലിൽ കുഴിച്ചിട്ട് ബയോഡിഗ്രേഡബിലിറ്റി സ്റ്റഡി ചെയ്യാം. സോയിൽ ഡിപ്പി അല്ലെങ്കിൽ ഏതെങ്കിലും എൻസൈമാറ്റിക് ഡീഗ്രേഡേഷൻ. നമ്മളൊരു പോളിമർ ഒരു 1 ഗ്രാം അല്ല 0.5 ഗ്രാം പോളിമർ എടുക്കുക, അതൊരു ഗ്ലാസ്സിനകത്ത് വെച്ചിട്ട് അതിനകത്ത് ഒരു എൻസൈം ഇട്ടിട്ട് ക്രിയേറ്റ് ചെയ്തിട്ട് അത് എൻസൈം ഒരാഴ്ച കഴിയുമ്പോൾ അതെടുത്തിട്ട് അതിന്റെ വെയിറ്റ് എടുക്കുക. അപ്പൊ വെയിറ്റ് ഇങ്ങനെ കുറഞ്ഞു വരുന്നതാണ് എൻസൈമാറ്റിക് ഡീഗ്രേഡേഷൻ.
ഇവിടെ മൈക്രോബയോളജി ലാബിൽ ഞങ്ങൾ ചെറുതായിട്ട് ചെയ്തിട്ടുണ്ട്.
അത് നിങ്ങൾക്ക് അത് ചെയ്യാവുന്നേ ഉള്ളൂ. അതൊക്കെ നിങ്ങൾക്ക് അവിടെ ഈസി ആയിട്ട് ചെയ്യാൻ പറ്റുന്ന ഒരു ഇതേപോലുള്ള ബയോപോളിമറുകൾ എടുക്കുക, എൻസൈമാറ്റിക് ഡീഗ്രേഡേഷൻ, പിന്നെ ഫംഗൽ മറ്റേ എന്താ പറയുക ആന്റി ബാക്ടീരിയൽ ഇത് വെച്ചിട്ടുള്ള ഈ കോളി പോലത്തുള്ള മറ്റേ ബയോളജി ആയിട്ടൊക്കെ ചേർന്നിട്ടേ അവിടെ ചെയ്യാൻ പറ്റും. ചോദിച്ചോളൂ. യൂണിഫോം സൈസ് തന്നെ നമ്മൾ പാർട്ടിക്കിൾ സൈസ് ആദ്യം മെഷർ ചെയ്യും. ഇപ്പൊ നാനോ പാർട്ടിക്കിൾ ഇപ്പം മാഗ്നറ്റൈറ്റോ അല്ലെ കോപ്പർ സൾഫൈഡ് നാനോ പാർട്ടിക്കിൾ നമ്മൾ പ്രിപ്പയർ ചെയ്യുന്ന ഈ പാർട്ടിക്കിൾ എല്ലാം നമ്മൾ MSc PG-കാരെ കൊണ്ട് PhD-കാരെ പിള്ളേരെ കൊണ്ട് ചെയ്യിപ്പിക്കും. എന്നിട്ട് നമ്മൾ അതിനകത്ത് സൈസ് 9 മൈക്രോമീറ്റർ അല്ലെങ്കിൽ 10 നാനോമീറ്റർ, മൈക്രോമീറ്റർ അല്ല നാനോമീറ്റർ, 10 നാനോമീറ്റർ റേഞ്ചിലുള്ള നാനോ പാർട്ടിക്കിൾ എടുക്കുന്നു. ആ നാനോ പാർട്ടിക്കിൾ ആണ് നമ്മൾ ഇതിനകത്തേക്ക് ചേർക്കുന്നത്. അപ്പം നമ്മൾ സൈസ് ഒരു പർട്ടിക്കുലർ സൈസ് തന്നെ നമ്മൾ എടുക്കുക. പിന്നെ ഈ നാനോ പാർട്ടിക്കിളിന് ഏറ്റവും വലിയൊരു പ്രോബ്ലം എന്താണെന്ന് ചോദിച്ചാൽ നമ്മൾ പോളിമറിനകത്തേക്ക് ഇട്ട് കഴിയുമ്പോൾ ഇത് അഗ്ലോമറേറ്റ് ചെയ്യും നാനോ പാർട്ടിക്കിൾ തന്നെ. അപ്പൊ അത് തടയാനായിട്ട് നമുക്ക് SDS സോഡിയം ഡോഡക്കൈൽ സൾഫണേറ്റോ അല്ലെങ്കിൽ ട്രൈമീഥൈൽ അമോണിയം ബ്രോമൈഡ് പോലത്തുള്ള ഫേസ് ട്രാൻസ്ഫർ ഏജന്റുകൾ ചേർത്ത് നമുക്കിത് തടയാനും പറ്റും. അപ്പൊ അവിടെ നമുക്ക് അവരുടെ ഗ്രോത്ത് തടയാനും പറ്റും. അതാണോ ഉദ്ദേശിച്ചത്?
ഈ ക്യാപ്പിംഗ് എന്ന് പറയുന്നത് അതിന് വേണ്ടിയിട്ട്
ക്യാപ്പിംഗ് ഏജന്റ് ആയിട്ട് ഉപയോഗിക്കാം. നമുക്ക് ഇവിടെ ക്യാപ്പിംഗ് ഏജന്റ് ആയിട്ട് ഉപയോഗിക്കാം. ചില സ്ഥലത്ത് PVP ക്യാപ്പിംഗ് ഏജന്റ് ആയിട്ട് ചിലർ ഉപയോഗിച്ചിട്ടുള്ള പോളിമർ നാനോ പാർട്ടിക്കിൾ ക്യാപ്പിംഗ് ഏജന്റ് PVP ചേർത്തിട്ടുള്ള അങ്ങനെയുള്ള വർക്കുകളുണ്ട്. പോളിവിനൈൽ ആൽക്കഹോളിൽ ചേർത്തിട്ട് ചെറിയ അളവിൽ ചേർത്തിട്ട് അങ്ങനെ വർക്ക് ചെയ്യുന്നവരുണ്ട്.
ഓക്കെ സർ, എനി അതർ ക്വസ്റ്റ്യൻസ്?
നിങ്ങൾക്ക് ഇഷ്ടമുള്ള എന്ത് വേണമെങ്കിലും ചോദിക്കാം കേട്ടോ.
Any questions? Questions ഇല്ല അല്ലേ? Okay. So we had a very informative and interesting class from Dr. Ramesan sir, and he very clearly explained how blends are made, methods for making blends. Then he also gave some useful tips for doing projects for our BSc and MSc students. That was very useful, sir. And then this antibacterial study, biodegradability for biopolymers. All these things were very useful, sir. Now I invite our BSc student Suganya Ramachandran for the formal vote of thanks. Suganya?
Ma'am?
Yes.
Good afternoon, everyone. Honorable dignitaries, distinguished guests, respected teachers, and dear participants. On behalf of Madras Arts and Science College, its entire fraternity and the organizing committee, it will feel immense pleasure to take this opportunity to propose a vote of thanks of our eminent speaker, Dr. M.T. Ramesan sir, the Associate Professor of Department of Chemistry, Calcutta University, who spared the time from his busy schedule to grace this webinar with extremely relevant address on preparation, sexual characteristics and properties of composites based on different polymer blends. Thank you, Ramesan sir, for explaining and demonstrating, explaining the different types of blends and the methods of preparing blends, conventional methods as well as latest methods, then the characterization methods, compatibilities, the synthesis. He also explained some work done his department where it has found that the blends have more properties like mechanical properties, then abrasions, resistant oil, then resistant flame, then retardants. All these properties are improved by preparing the blends composites. Then also I would like to take this opportunity to place on record our heartily thanks to Shantakumari ma'am, head of the Department of Chemistry, Madras Arts and Science College,
for the great support and guidance she has extended to all of us. I also extend my sincere thanks to Lindsay Ma'am, Assistant Professor of Department of Chemistry, Majlis Arts and Science College, for the enormous cooperation in the organization of this section. And also a big thanks to all the one who worked behind the arranging such an informative event session. We have been very fortunate enough to be backed by a team of very motivated and dedicated faculty members of postgraduate department of chemistry, Majlis Arts and Science College. My team and thanks to all dedicated with great enthusiasm and made it a successful one. Once again, thank you all. And thanks all of you for being with us this section. Thank you very much. Thank you, sir.
Thank you, Suganya.
Thank you, ma'am.
Thank you, sir. Sir, thank you very much.
താങ്ക്സ് ടീച്ചറെ. ഓക്കെ, താങ്ക് യു.
സർ, ഞങ്ങള് ചില പ്രോജക്ട്സിന് ഗൈഡൻസിന് വേണ്ടിയിട്ട് സാറിനെ സമീപിക്കാം.
സംശയം എന്തെങ്കിലും ഒന്ന് ചോദിച്ചാൽ മതി, ഞാൻ പറഞ്ഞു.
ഓക്കെ സർ, വളരെ താങ്ക്സ്. ഇനിയിപ്പോ ഈ കൊല്ലത്തെ പ്രോജക്ട്സ് ചെയ്യുന്നതും കൺഫ്യൂഷൻ ആയിട്ട് കിടക്കുകയാണ്.
പി ജിയുടെ പ്രൊജക്ടുകളെ ഇപ്പം ചെയ്യുന്ന ഒന്നും അതിനെക്കുറിച്ച് ഒരു ഇത് വന്നില്ല. അപ്പം ഈ ആഴ്ച, അടുത്ത ആഴ്ച യൂണിവേഴ്സിറ്റിയിൽ നിന്ന് ഒരു ഇത് ഉണ്ടാവും എന്നാണ് പറയുന്നത്.
സെക്കൻഡ് സെമസ്റ്ററിൽ ചെയ്യേണ്ട പ്രോജക്റ്റ് ആയിരുന്നു. അപ്പൊ അവരിപ്പോ ഫോർത്ത് സെമ്മിൽ എത്തിയിട്ടുണ്ട്. അപ്പൊ എപ്പോഴാ ചെയ്യേണ്ടതെന്നുള്ള ഒരു ഐഡിയ ഇല്ല.
അതെ, അതിപ്പോ ഇപ്പം ഇത്തവണ കോളേജിൽ തന്നെ എന്തെങ്കിലും ചെയ്യണം